I'm learning neural networks using PyTorch, using this PyTorch official documentation. And I will just be sharing what I've learned so far in these videos. So I would definitely not recommend completely relying on what I'm saying in these videos, but this is my experience and I just wanted to share. And I think you learn better when you try to explain topics. So that is my main reason. And I thought the best way to explain is record a video and just go through what I've learned. And what I'm going to do is I'm not going to like code this while you're watching this video. I'm going to learn on my own time, and then I'll create a Jupyter notebook for this particular chapter, and then I will review that chapter on the Jupyter notebook and just discuss what I've learned. And it's fascinating that I think I've learned quite a bit, and then I will try to explain something and I'll get stuck. Anyway, let's get started. So first we just import torch and numpy as np, and here we have a data, just a plain Python list, and what we're doing is using the torch tensor method. We are converting that data Python list to the tensor. So we can see if we print this here, I should actually print the type of the data just to see, but it's pretty self-explanatory if you have some experience with Python. What did I do wrong? Torch is not defined. Okay, I just need to run these as we go along. Just takes a little bit, and then we should see the print statement. So there we go. We have the Python list and we have a torch tensor here, and the size of that tensor is 2 by 2. And why is it 2 by 2? So each element inside this nested tensor, so this element has 2, and then we have 2 of these tensors here, so which is why we have the size 2 by 2. And now you can also see here, using that same data Python list, we are creating a NumPy array. And we also, so if we print this statement, we'll also see like the first one being the NumPy array. And then what we do is we use torch from NumPy method. And if we pass the NumPy array, that also gives us the torch tensor. So you can see that we can go from a NumPy array to a torch tensor, and we can do the vice versa as well. So which we'll get to later in this video. And then we have here a method called onesLike. So basically what onesLike does is it takes a certain, so this X data tensor from here, we created. So it takes a tensor and gives you the tensor with a similar shape, but just filled in with ones. And it does not actually change that old tensor, right? So it just gives you a new tensor, but it just takes the shape of the tensor in the input here. And as we print here, so you can see all, if we just print that, all tensors have 1, and which is what it did, onesLike. And then we have here, so we're using randLike, and we're again doing the same thing. So we're saying, hey, give me another tensor, but with the same shape. But in this case, we don't want the onesLike, we don't want the randLike, so we want the random. And as you can see, I've printed that here. I'll just reprint this. As you can see, they're just random, right? So when we're asking, just make sure the torch data type is float. And then I printed a bunch of these here when I was learning, so we can skip that. And we have shape here, so we'll start from here. So we're defining a variable called shape, and it's just a tuple with number 2 and 3. It just means we want tensor of 2 by 3 dimension. And when we do rand tensor, so torch.rand, random, so we're passing the shape and we just get the random tensor with 2 by 3. So we have 2 tensors here, and then we have 3 elements in each of those tensor, which is the size. Now we have ones. So if we pass in that same 2 by 3, sorry, I'm just going to run these because then I won't be having any issues down on the other section if we're referencing any code. So ones tensor basically, I mean, as you can guess, it just gives us the same shape of tensor but with ones. So let's just print that and see it in action. Print, not tensor, ones tensor. And there we go. So we just have ones here. And we are asking for, so you can also do just type in the shape directly rather than passing the shape, which is the same thing. And also, so I'm just going to check quickly. Yeah, that's what we did. And here, if we just run this zeros tensor, so it again does the same thing, just prints, gives you a tensor with all the zeros in it. And then if we just print this section here, we're printing the shape of the tensor, data type of the tensor, and the storage of the tensor. So where is it stored at the moment, right? So currently it's saying stored on a CPU. So that's where the computation will happen. And you can also do on GPU. So for example, here operations on tensor, you can check and you can move the tensor to CUDA. So CUDA basically is a layer, an application layer that allows you to access the graphics card to process the tensor computation, right? So you need to have a graphics card that supports CUDA as well. And in that way, you can just, if you move your tensors to CUDA, or if you set your device to CUDA, then you can run your computation there. That's my observation so far. And then we have here, so we're basically learning how to index a tensor, right? So we have a ones tensor of 4x4, which is basically just number ones. And if we just, I'll probably just do rand for the sake of clarity. Like if they're just all ones, it's hard to know which, like how this slicing worked, right? So first I printed the tensor itself, and now we're checking how the slicing works. So when we did tensor 0, obviously we kind of exactly like Python, we got the 0th index, tensor on the 0th index on that outer layer, right? So 0.293, so we got this here, right? And when we did first column, so we here did tensor colon comma 0, right? So we're saying we want the column 0 and we want everything. So when we did that, let's see what we got. So if we look at this example, so we got 0.29, 0.114. So as you can see, we've got this list here, right? So we wanted everything from 0th column, and we got all of those. And then last column, so we are saying these 3 dots here, and then -1. So by referencing -1, we're just getting the last column. It should be 0.03, 0.75, 4829, and then 5870. So that's basically how you would reference any of the tensor. And what did we do here? So we are also referencing that, and we're setting it to 0. That's an interesting one. So we did print it. Let's just print. So let's just print a tensor after that. We can just do that here. If you press, I think, escape B, it just spawns a new prompt. So what I can just do is print tensor, and let's just print that. So now we can see we made all the column, so everything in column 1, we set that to 0, right? So that's again another powerful operation you can do, right? That's very, like, to manually do that is quite cumbersome, but that's, yeah, you can just do that with one simple reference here like that. Operations, I should say. And we have joining tensor, how to join a tensor. So concatenation, so there's a cat method, and you can just basically pass in multiple tensor, and we're asking the dimension to be 1, and then if we print that, so it just concatenates all those tensor into a large tensor. Actually, let's try this out, because when it says concatenate, I see what it's doing. It's really like, what happens, I want to try this. So what happens if we just do T2 equals to, and I don't want the concatenation to be on the outer layer. I just want, I don't think we can pass in like that. So this is concatenating tensors, basically. Let's just print each tensor. No, that's just so let's just run this first. And let's just see what it's doing here, right? So this is the concatenation. And this is the tensor here. We're concatenating it 3 times. So 0 0.29, 10, 039, 04. So I'm going to continue throughout this video, because I don't want to extend this video. But what I'm going to do is, on the next session, I will tackle this and explain how this is working, and then we talk about the rest of the chapter, because I don't want to make this video too long. Actually, I'm just going to end the video now, and I'll start the next video with this this explanation, and also the like matrix multiplication explanation. So I'll need to prepare for that. Thank you for watching, guys.